The wheel is one of the biggest parts of history. As you can see from the Stone Age, from back in the 1800s with Dennis Walter's steel wheel, or nowadays with the average tire. You see wheels everywhere, and there's no escaping them. Now this is a screenshot of an animation I'm going to show you. It's highlighted a point on the graph on a circle, and it traces its path. Now, so you can see the point is only hitting once on the ground. I will show you a demonstration. In this demonstration, I'm going to explain to you what happens at the point of contact on a wheel. Okay, here we go. Now I have some Vespar paintbrush, and a roll of duct tape that will serve as the wheel. This is going to be a very rough demonstration or example of what really happens. So first, you need to take this and paint a little line on it. See the line? Now, when I roll this, you see that? See this mark? This mark represents the instantaneous point of contact with the ground and the wheel. Because when a wheel is a perfect circle and the point of contact is always changing, there's only an instant at which the surfaces touch each other. So from this demonstration, at the red mark in this picture, that is the instantaneous point of contact, and that point of contact's always changing. In the photo, there was another point as the tape continued to roll. There was another red line. Now, because this point is always changing, that if you were to paint the whole roll red, there would just be one big line. That would represent all the points at which the duct tape touched the actual paper. Now, because of that, there is no relative motion at the instantaneous point of contact. That at that instantaneous point, it is stationary. I'll explain with this equation. Velocity equals radius times the angle all over time. Now, in this picture, as you see here, there are 4 different points where the velocity is going in a specific direction, which is the tangent line because it's going clockwise. That's the velocity, is the tangent line. Now, if you were to take the velocity of the lower point minus the higher point, or the top point, it would get 0, because at that lower point is the instantaneous point of contact, and at all these 4 points, there is no relative motion.